Welcome to Aryabhat Center for Theoretical Physics. This is third lecture on this lecture series linear algebra, and in this lecture we are going to learn distance between vectors, angle between two vectors, and projection of one vector to another. So first of all, assume there are two vectors u and v whose components are a1 to an, b1 to bn, which belongs to vector space Rn. So how we can find the distance between these two? Distance between vector u and v equal to the magnitude of the difference between component of u and v. It means root a1 minus b1 square plus a2 minus b2 square plus dot dot an minus bn square. So this is the difference between two vectors. And how we can find the angle between two vectors? If angle is theta, then cos theta is u dot v dot product of these two vector divided by the product of magnitude of individual vector, magnitude of u and magnitude of v. And now we can also find the projection of vector u on v. Projection of vector u on v is dot product of u v divided by square of the magnitude of the vector v and multiply by the vector v. This is the projection of u on v. And let's take an example. U is 1 minus 2 3, v is 2 4 5. Distance is simply root 1 minus 2 plus minus 2 minus 4 square plus 3 minus 5 square, and we will get root 41. And calculation of dot product of u and v, u dot v is 2 minus 8 plus 15 is equal to 9. Multiply each component 1, 2, minus 3, 4, 3, 5. And individual what you call magnitude of u is 14, magnitude of v is 45. Now calculation of angle, cos theta is equal to uv divided by magnitude of u, magnitude of v, and we will get 9 root 14 root 45. Again, projection of u on v is u dot v divided by v square v, and we will get 2 by 5, 4 by 5, 1. These are the component of projection of u on v. 2 by 5, 4 by 5 and 1. Now this is the representation of projection. Projection of u onto v is u star, and magnitude of u star is u cos theta, and we know that according to dot product cos theta is u dot v divided by magnitude of u and magnitude of v. So this is the projection of u onto this v vector.